Okay, so continuing with number 29. So when we do the derivative, we see that we end up with a quadratic. And so, if you think about a quadratic, it's a parabola. So you are either going to have 1 0, 2 zeros, or no zeros. So for, what are we trying to do? We're trying to show that f has either 0 or 2 local extrema. So here, in this case, this would have 2 local extrema because the derivative is positive and then negative, and then it goes from negative to positive. Here, we have no critical points, and here we have 1 critical point, and it stays above, so there's no sign change. So therefore, f has either 0 or 2 local extrema. And then give an example of each possibility in part A. Okay, so an example of, so for part B, an example for no extrema would be f of x equals x to the third. So this is the example, kind of like this one right here, where we get 3x squared, and that only has a critical point at 0, but there's no sign change. And then let's see, 2 local extrema. And then maybe x to the third minus x would be another, because then when we do the derivative, we get 3x squared minus 1. And 3x squared minus 1 is going to be like this one, where it's going to go below the x-axis. So that gives us 2 extrema. Okay. So the next one, let's see, is number 53. So number 53, we want 2 positive numbers that have a sum of 60. What is the maximum product of one of the numbers times the square of the second number? What's the maximum? Okay, so so 53. So the 2 numbers are going to be x and 60 minus x, and we want a function such that the product of one number times the square of the second number. So I'm going to do 60 minus x times x squared, just because that's easier than squaring the 60 minus x. So we have f of x equals 60x squared minus x to the third. So then we're going to do the derivative. We get 120x minus 3x squared. And then we can set that equal to 0, so I can take out a 3x. And we're left with a 40 minus x. So we have critical points at x equals 0 and 40. And let's see, it says, oh, what is the maximum product? So we have 0 and 40 and 60. So if we choose a value between 0 and 40, plug that in, say 20. So that's going to be positive, and then that's negative. So that's going to give us a maximum. So if one number is 40 and the other number is 20, what is the maximum product? So it's going to be one number, so it's going to be 20 times the square of 40. Sorry, I'm going to put in here f of 40. So 20. And that is D. Okay, so the last one is, I believe, 55, yes. Okay, so 55, it says, or no, wait, is it 55? Yes, what is the maximum area of a right triangle with hypotenuse 10? Okay, so we have 10. So we want the maximum area of a right triangle. So here we have x and we have y. So we know x squared plus y squared equals 10 squared, so we can solve maybe for y. So we have 100 minus x squared, so y is going to be the square root of 100 minus x squared. So our area is going to be 1/2 base times height. And now we want to, so I have 1/2 x square root of 100 minus x squared. So I want to maximize that. So we're going to do the derivative. Now we have to do the product rule. So we have 1/2 x. So now we have 1 times 1/2, 100 minus x squared to the negative 1/2 power times negative 2x plus 1/2 times 100 minus x squared to the 1/2 power. So this is going to give us a negative 1/2 x squared times 100 minus x squared to the negative 1/2 plus 1/2 and then 100 minus x squared to the 1/2. I'm going to factor out, let's factor out a negative 1/2 and then 100 minus x squared to the negative 1/2 power. So we're left with an x squared minus 100 minus x squared. Okay, so we get a negative, let's see, we're going to get, let me rewrite this, negative 1/2 x squared to the negative 1/2, and then we get 2x squared minus 100. Okay, so then, let me just kind of go down to the next page. We get, in the denominator, we get 2 square root of 100 minus x squared, and then there's a negative sign out in front, and we get 2x squared minus 100. So if we set this equal to 0, we get critical points. Well, let's see, so that would be a negative 2x squared plus 100 equals 0. So 2x squared equals 100, x squared equals 50, so x equals square root of 50. Okay, and we don't need to worry about where it's undefined because that's going to give us x equals 10, and that actually doesn't make sense since the hypotenuse is 10, so the leg has to be smaller than that. Okay, so now we want to do what? We are trying to maximize that area. And our formula was up here. It was 1/2 times square root of 50. And then the square root of 100 minus square root of 50 squared. So we have 1/2. Square root of 50 is going to be 5 root 2. And then under the square root, we get 100 minus 50, which is the square root of 50, which is going to be another 5 root 2. So, okay, so we get 1/2 of 50 is 25, and that is answer B. And we're done.